Thank you everyone for joining us. And for those of you who were here with us yesterday, welcome back. We're so excited to have you here for the second and final day of our Digital Jewelry Summit. My name is Rachel, and today I'll be joined by Patrick Dobbs, Fernando Cortez, Chris Leonard at Stoller, and a member of our team here at B9Creations, Eric Henriksen, who will all be helping facilitate the webinar. First, I'm just going to quickly introduce B9Creations and explain a little about what we do. We offer high-resolution additive manufacturing solutions. From 3D scanning to 3D printing, our high-precision platforms have earned the trust of jewelers worldwide. And if you'd like to learn more about our jewelry solutions, please visit b9c.com/jewelry. Here's today's agenda. We'll be starting with designing for 3D printing with Patrick Dobbs. Then we'll move into 3D scanning for jewelry with Fernando Cortez. Next, we'll discuss industry trends and emerging tech with Stoller and B9Creations. And at the end, we'll open the floor for questions during an open forum Q&A session with all of today's panelists. Please note, we are being pretty flexible with the schedule today, so we will do our best to stick to that published schedule, but a session may run a few minutes longer or shorter than we anticipated. I just wanted to make sure everyone was aware of that in case you're planning to hop off and rejoin for a later session you're interested in seeing. We will be taking a short break each hour in between sessions, so you will have a chance to get up and take a break if needed. I also wanted to mention that we are recording this, so if you need to step away or if you miss a session, we'll be sending the recording out later this week or early next. All right, and now we're ready to kick off our first session, Designing for 3D Printing with Patrick Dobbs. During this session, Patrick will let you in on the secrets to designing for the perfect print every time. He'll reveal unique methods to overcome common design challenges that hinder the success of your 3D prints and more. If you have any questions throughout the session, please type them into the Q&A tab or chat to the panelists and we'll answer them at the end. Here's the agenda for Patrick's session. First, he's going to present a piece on planning ahead, then move into best practices and design sheets, positioning strategy to eliminate supports, strategies for larger pieces, and then he'll finish off with some information about 3D printed molds. All right, and now I'm going to kick it over to you, Patrick, so you can go ahead and introduce yourself and take over from here.
Well, good morning. I hope everybody has a cup of coffee. It's cold here in Austin, Texas. We went from 90 degrees a few days ago down to, I think it got to 29 last night. So it's been kind of interesting. We got a bunch of ice on the ground and everyone's crashing. So an eventful commute in. But welcome, and we're going to kind of touch on some interesting things and just some discoveries that I've made, and learning about a little bit about strategy and how we're going to just think outside the box a little bit when it comes to designing and printing, and just coming up with some really good strategies to eliminate a bunch of labor, removing supports and stuff down the road. You can design a piece so you can get where you don't have a whole lot of supports to remove down the road. So anyway, Rachel, how do I go about sharing my, oh, there it is. I got it. All right. So give me just a second to find my, there we go. All right. So one of the things that I wanted to talk about is planning ahead. And this is something that was really difficult for me when I first started, 3D printing things that I had created in CAD. One of the first things I want to talk about are just flat surfaces in general. Anytime you end up with a flat surface that you need, it's best to kind of plan ahead and have a strategy for dealing with that flat surface. Flat surfaces, they never end up being flat. They kind of sort of end up a little bit recessed, a little bit dimpled, and stuff like that. So if you look here, I've started with just a flat surface like what we were talking about with this is a concept moving forward. And then maybe the design, maybe, you're going to create a die like this one in the top middle row. So based on that, once it's printed and then cast, you always end up with a surface or multiple surfaces that end up looking like this in the top row, right here. What ends up happening is when it's cast, you'll end up having a little bit of shrinkage, and your middle part of your surface is going to dip down. Then you're going to try to sand that down, and everything is going to end up just not right. So the best way to plan ahead for that is to just create a little bit of a dome surface. I take, and no matter what I'm doing, if it's a flat surface, I make it domed. And then it's easier to make something that's domed after it's cast flat than it is to try to start with something flat and keep it flat. So again, it's just a lot about strategy. Plan ahead, figure out what's gonna work. If you want something to end up flat, make it slightly domed and sand it to be flat. Because if not, you'll end up just chasing that recessed surface a little bit from where you've had a significant amount of shrinkage. So one of the ways I do it is you can use like a bounding box or something like that. Design it the way that you want it to be, and then just take a bounding box, take your control points, and then just slide them up slightly. And it doesn't have to be a whole lot. Just a little bit of dome will help quite a bit when it comes to being able to sand that off and create a flat surface. So there you have it on the die that I was showing here. And that's just a really good example of like having to design a flat surface. I don't know that I've ever designed a die like that, but as long as you have that mindset moving forward, let's look at possibly doing something like for a halo. So again, it's the same kind of thought process. I would start with a profile and make the profile underneath just slightly arched, and then once this is created, you'll end up with having to only support in one area instead of all the way across. You end up with some like overhangs trying to deal with your flat surfaces that end up creating issues after it's cast. You'll have a lot of cleaning up where those supports were. So basically what we're looking at here is we're looking at a halo that I just drew up as an example. So let's look at the profile. If you look here, I designed it with that arch like I was talking about. And then moving forward, this is also a little bit of a design trick that if you take and design and take that profile and angle it slightly to the outside, so your diamond tables, once it's designed and they're put in place, you won't have this issue of all of the diamonds trying to flash the tables at the same time when you're looking directly from above. So this is just something, just a little bit of a cheat. If you do make it where all the tables are flashing exactly straight up, if there's any error in the stone setting, it'll always show up. So if you just move them where they're slightly to the outside like that, it not only helps with the 3D printing, but it helps with the stone setting later on. And it's easier to cover up your mistakes. And I make lots of mistakes. So that's one of the things that I've done for a long time. And it helps not only with the 3D printing, but also, with the final product. So looking back at this is the profile that I used. all I did was angle this slightly to the outside before I swept it. And then I want to talk about the cutters that you use. What ends up happening is if you use a cutter that has very straight and sharp angles to it, if you think about, once that's invested and then burned out, you end up with these little sharp mountains in your investment. And if you think about the investment, that investment is a lot like chalk. So a lot of times what I'll do is, if I'm curious to how something's going to look, I'll actually bullion it out and look at what the empty cavity inside of where the investment is, inside of that, once it's burned out, because this would be the channel that the metals can be flowing through. So you don't want to use really, really sharp cutters and things like that. There's several different ways of doing it. I found that if you use a cutter like this, it works pretty well. You can also take a sphere and snap it to the culet so that it'd be round right here. That does a lot of the same thing, so that you don't end up with just a completely sharp edge. Any of your edges that you can round up and stuff like that, it's going to give you a lot better print, and then also a lot better casting after it's invested. I avoid, as much as possible, having pilot holes that are drilled all the way through in the 3D print, and that's for several reasons. Again, if you're looking at this is what it looks like inside the investment once the ring is burned out, you're going to have the metal rushing through here, and these little pilot holes end up being little tiny pillars that, like I said, are basically a lot like chalk. That metal's coming in with quite a bit of force, and it breaks those off, and then you end up with investment inclusions in your casting, and you end up looking at it and going, wow, why do I have this strange looking hole right here in my casting? You need to figure out and learn how to identify your different types of porosity and what's caused it. You look at it and you may think, well, this is porosity caused by shrinkage, and this is porosity caused by expansion or whatever. But whenever you see kind of a geometric shape that's porosity in your casting, you can pretty much guarantee you had a piece of investment break off in the casting. And to avoid that, I don't have any pilot holes in anything that I'm doing. If you are going to have pilot holes, I try to make them at least 0.65 millimeters. And you don't want that to span very far, So it's just something to be mindful about when you're designing, when you're creating something. Try to figure out, the best strategies. Try to figure out while you're doing it, think about it in the obverse. Try to figure and think what this piece is going to look like inside the empty cavity of the investment once it's burned, completely burned out. So again, this would be a really good example of what this halo would look like when it was burned out. And you can tell we've got, pretty solid places where the pilot holes would be. And they're, little recesses under where the culet is. That way, if you go to, once it's cast, you can drill those out, and they're clearly marked and everything like that. So even if you decide not to drill it out, you have plenty of space under your diamond for cleaning and You know, and then also with stone setting, you don't want that culet hitting the bottom of that and altering the angle of how the stone is set. So again, this is how I would draw it. Again, keeping soft edges and no real hard points or anything that can be knocked off during the casting process. Okay, so here's the ring with the halo kind of on top. And again, this is something, and you know, you hear this all the time. It's like, well, you should never cast prongs. If you do cast prongs, if you've done the prongs similar to this, what you'll see is you'll have a little island down here when it goes to print, and you'd have to add a support right here. Well, those supports end up being inside the design and difficult to remove. So if you were strategizing, you would want to tuck your prongs in similar to this, and then you've eliminated that need for support going directly to that prong. And it doesn't seem like a lot, you know, it's just a few minutes here and there. But if you're making one of something, it's probably not, you know, removing 2 or 3 or 4 extra supports isn't that big of a deal. If you're making 10 of something, it ends up, you know, costing you quite a lot of time. So you end up trying to figure and design with these strategies in mind, and you'll just save yourself a lot of time and labor, a lot of cleanup. If you notice, the bottom of the halo is slightly, you know, slightly domed. So you'd only have to add supports along this edge. You know, that ends up saving you a whole bunch of time, because that's a difficult area to get in and polish once it's cast. So you can kind of see another angle here of how you might want to go about doing that. Again, you just need supports to the outer edge and not necessarily up underneath. And it just ends up being, you know, quite a time saver there. Okay, so let's look at positioning strategy. And this is just something to kind of think about. Once the piece is designed and you're importing it into your getting ready to slice, I'll take a surface and just draw a surface in the software, in the CAD software, and then move this surface up and down and look at it from underneath, because these are going to be the areas where you need to put supports, you know. So you may look at it and go, that's fine, I can put supports all around this outside edge here. Or if you slightly angle the ring, you'd only have basically one area where you would need to put a support. So you can just rotate it and then slightly angle it, and you're going to end up having to put a support here at the bottom and one there, and maybe just a couple more for just to help hold it in place. But if you use this trick of just putting a surface in there, you can move it up and down, and like I said, you can look at it from underneath, and then you can easily tell where you're going to need supports once you've imported it into the B9 software. Okay, so this is an interesting concept. I had this problem a while back. I had to cast a very large ring that had a great deal of detail here on top, and it was actually like a Porsche logo on top. If anyone's ever seen that logo, you know there's a lot of detail in it. And then trying to make something that would burn out clean and also have the detail in the print. So I printed it in emerald green, and we cast this thing, I bet 10 or 15 times, trying to come up with a strategy to make sure that it would burn out clean was really, really difficult, because you're talking about burning out a tremendous amount of resin. And the process that I came up with that worked really well was I designed it with this lattice work on the inside. So I basically designed and printed the ring hollow with supports built in. And the reason I did that is because we won't be burning out near as much resin as if you're, burning out something that's completely solid. So what we ended up doing is printing it just like so. That left us an area here for the resin to drain out of, and this will also be where we ended up adding the sprue in wax once it was printed. In doing so, ended up spruing it just like this, and we're talking about something now that'll burn out a lot cleaner than having something that's completely solid and full of resin. So the way this works is you add a wax sprue to it and make sure that it's sealed all the way around, so that you don't want any investment getting inside of the ring. When you go to invest this, you can't vacuum it, because the vacuum process will suck investment into the interior of the ring. So the best way to do that is create some investment, vacuum it, remove the bubbles, get everything where it's really clean, well mixed and stuff like that, and then take your sprued up piece and then just dip it in that investment and build up a coating, a thin layer of investment. You can let that dry a little bit and then dip it again, and then that way that'll prevent you from having bubbles when you actually invest it without vacuum. Once this is done, all you really have to do is burn it out with the traditional burnout schedule. Your sprue is going to burn out first, which is wax, and then that's going to expose the interior of the ring to oxygen during the burnout process, and so the ring will burn out a lot faster and a lot cleaner. So you can do this with anything that's large. You just have to kind of have a strategy while you're doing it. Larger bracelets, larger gents rings, anything like that. I've got where I do it this way from now on, and you just don't have any of the issues with expansion, any of the issues with ash or anything like that, because you've eliminated 90% of the resin. Okay, so here's another interesting concept, and if anyone's ever watched any of my other webinars, we've talked about this quite a lot. Sometimes you end up with something that is difficult to print, and let's look at this. This piece here, we had all of this scroll work. And if you look at that, there's no easy way, no good way to add supports to that to actually get it printed. You'd have supports everywhere, and there'd be supports that, once it's cast, you'd have to take off. And then those supports, you're talking about a lot of labor cleaning up the casting and cleaning up where those supports were. So we've developed this process of 3D printing rubber molds, and this works really, really well. It was one of the things that whenever you have a concept in your head about something, you think, well, I wonder if this will work. This actually worked the very first time I tried it, and it worked really, really, really well. And it was just kind of shocking how easily and how beneficial this is to manufacturing. So what I did is put the piece in it, and I just drew the mold, basically split it into a top and a bottom, added where I wanted any of my locks to be to keep it from moving around during the wax injection process, and then just basically bullioned out the center out of both sides, and you end up with something that's easily injectable. You can get into some pretty complicated molds, which if anyone's interested in that, I actually wrote a white paper on it that you can get from B9. Here's the second part of this. What I was doing with this is I was wanting this butterfly to be two-tone. So I made the mold, the initial mold, took that piece, made sure this would inject well like this, and then I cast the yellow gold part, snapped it into the rubber mold that I had created of the whole butterfly, injected the wax around it. From there, it went straight into a flask to be cast in silver. So we have the yellow gold inserts and the silver casting around. There's no, when you do this, there's no assembly process because the piece is cast in place. You can actually have, and I've done this on other molds where I had supports that actually went directly through. You can see there's one in this example right here. So once that was injected, it was a simple matter of putting it in a flask, burning it out. Ended up with a silver casting. And at this point, all I did was take the casting out of the flask and tumble it, and ended up with a two-tone piece with no assembly at all, cast in place. So this is a benefit of being able to 3D print rubber molds. Like I said, it's also a way of thinking outside the box. It's all about strategy when you're designing and using 3D printing. So, finding a good strategy, looking at the piece, figuring out the best way to do it that's going to eliminate the most labor. Labor ends up costing you. So however you can do it to eliminate labor, going to be money in your own pocket. So that's about it. That's about all I have for you today. If you have any questions, I'll be around later, and hope to talk to you all then.
Thank you so much for that, Patrick. We actually have one question for you. If anyone else has any questions, go ahead and type them into the Q&A tab, or go ahead and chat them to the panelists, and we will ask Patrick. The first one that we have here is, what's the difference in casting temp for silver versus gold?
There's a lot of things that influence that. And that's really a difficult, almost a loaded question, if you will. It's going to depend on the piece. It's going to depend on how heavy it is. It's going to depend on, if you're casting the exact same piece, say a gents ring, and one of them is in gold and one of them's in silver, find out what the manufacturer is, basically the manufacturer of the metal or the alloy. Find out what their recommendations are, and go from there. Sometimes it can be 100 degrees, sometimes it can be 200 degrees. The larger the piece, like those gents rings right there, if I was casting that in silver, I may cast it at 300 degrees. It's just, there's so many variables in that'd be a hard one to answer. But I would say check with where you're getting the metal and find out what their recommendations is on the different metals, and just use that difference between silver, and then find the casting temperature of whatever piece. If it's large, you're going to want to use a lower casting temperature. If it's small, you're going to want to use a higher one.
Awesome, thank you. The next one that we have here is, what is the minimum spacing between supports for horizontal edges? For example, halos.
Oh, well, in the B9 software, there are guides in there that kind of show you, it'll turn the model yellow where it needs to have a support. And that's very accurate on there. I use that a lot as a guide. Typically, I wouldn't go more than about a 0.5 millimeter to 1 millimeter, but depending on the angle, you know, if it's almost completely flat, then you're going to want quite a lot of supports to support it. I'd put them around a 0.5 millimeter apart. But like I said, you can eliminate a lot of that by angling the piece to one side and then rotating it. And that's going to eliminate a lot of the support. So again, the goal is, in my mind, to eliminate as many as you can. And then if you can't, then keep them around a 0.5 millimeter apart.
And can you tell us some of the quirks you've found with printing in this resin specifically? I believe that's in regard to silicone.
You know, silicone's fun to print in. It's not hard to print because you're printing flat usually, so it's a pretty simple way to print. You don't have to have a lot of supports. If you do have a lot of supports, they because they're silicone, they come off pretty easily. But silicone's a dream to work with, and don't have a whole lot of shrinkage. If you do have shrinkage, it's consistent. So on a particular thing, you may go, you know, I had 5% shrinkage. So then you can pretty much across the board know that you're going to have 5% shrinkage on anything that's printed at that angle, you know. So it's real easy to go through and figure out the little quirks. It's a lot easier than some of the other resins that I've worked with. You know, there are a lot of different resins that are unstable, in my opinion, that I've worked with, you know, throughout the years. Silicone just has to be shaken real well, and you have to keep it mixed, but it smells good. That's kind of a neat thing. It almost smells like a men's cologne, and so that's one of the neat quirks, I guess. So
Well, yes, that is definitely a unique quirk of it. Do you only dome horizontal surfaces?
you know, the way I design, that's kind of a personal preference, really. I don't like flat surfaces at all. It's just you end up with, if there's going to be a problem, it's going to come out on a flat surface. So I try to eliminate as many flat surfaces as I can. Even if it's something that I want to look like a flat surface, I still keep it relatively domed. Not only on horizontal surfaces, but on vertical as well. So, you know, if you go back and think about the halo that I did, even the outside edges of it were slightly, you know, slightly had a slight arch to them. It's a lot easier to polish. You can polish something and make it look consistent if it has that slight dome. Like I said, even on the vertical surfaces, because you're only hitting that a much smaller amount of surface area when you go to polish. So if you're polishing something that's vertical and it has that dome to it, you're hitting a smaller area with each pass of the buff. So it makes it easier to polish. it makes a much softer feel. It makes more comfortable jewelry, you know, in my opinion. But like I said, it's a personal preference. I've known designers in the past that used a lot of hard flat surfaces. The one that comes to mind is John Atencio. He everything he had was very flat, hard, crisp edges and stuff, and it has a nice look to it. It's just manufacturing. In my opinion, it would be hard to do, you know, hard to do quickly. So.
And our next question is, when you talk about the signet ring, it seems very easy to explain it for one ring casting, but what about when doing 25 pieces in a flask?
I'd use the same process. You know, you can eliminate the bubbles, like I said, by dipping it. You know, you can make even a tree and have enough investment to dip it, or even use like a paintbrush and paint it on. And typically I wouldn't try to do a tree like that. If I was doing 25 of those, I'd do 25 individual flasks done exactly the same way. But it's gonna save time in the long run. You're gonna have less issues with your casting once it's finished. So whatever extra time it takes in the beginning, you're gonna make up the time on the back end on finishing and having to deal with any expansion or ash that you may have in your casting. So.
Awesome. And it looks like those are all the questions that we have for now. And I just wanted to mention before we end this session that if you are interested in learning more about 3D printed jewelry molds, we did put on a webinar a while back where Patrick really dove into the entire process. So that has some great nuggets of information. And if you are interested, you can check that out at b9c.com/jewelry molds.